In this video I'm going to look at just number 14. So the directions on 14 are to find the equation of the tangent line to the curve at the given point. So the first step is to find the derivative. The derivative will help us find the slope of the tangent line, and then we'll use the point to find that exact slope and then write our equation. So step 1, find the equation of a tangent line. Step 1, find the derivative. For this problem we're going to have to do the quotient rule. So we're going to do the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now you can leave it like that if you want and go ahead and plug in your x value. Oh, I forgot to square the bottom. You can leave it like that and go ahead and plug in your x value. You can try to simplify it a little bit and then plug in your x value, whatever you want to do. But if we know we're looking at the point at 0, -1, then we know we're going to use 0 for x. So I'm going to go ahead and actually plug that in to figure out what our slope is at 0. So I want to find y prime of 0. So that's going to be 0 squared plus 1 times 2 times 0 minus 0 squared minus 1 times 2 times 0. And that's going to be over 0 squared plus 1 squared. Well, your top, we basically have 1 times 0, so that's going to be 0, minus -1 times 0. So again, that's going to be 0. So I'm going to have 0 on top, and on bottom we have 0 squared plus 1, and then squared, so that's going to be 1 squared, which is 1. So we get 0 over 1, which is 0. Alright, so our slope is 0. So if you want to think about this, y equals mx plus b, and your slope being 0, and then essentially you'd plug in 0 for x and -1 for y, which is going to tell you that b is -1. So if b is -1, could you say 0x plus -1? Sure, but I'm just going to say y equals -1. Okay, so we're actually going to have a horizontal tangent to that curve at that point. It's going to be a horizontal line, y equals -1. Part B, again, same direction. I want to find the derivative. That's going to tell me the slope of the tangent line. Then I'll write the equation. So to find the derivative of this, I'm going to need to use implicit differentiation. So I'm just going to take the derivative of each term. So the derivative of x squared is 2x plus, I've got 4xy, so I'm going to look at that as 4x times y, and I'm going to do the product rule. So the first times the derivative of the second plus the second times the derivative of the first. So the second is y, the derivative of 4x is 4, so that would give me just plus 4y there, plus the derivative of y squared, which is 2y dy over dx, and then that's going to equal the derivative of 13, which is 0. Now, before I go plugging in my 2 for x and my 1 for y, I'm going to solve for dy over dx so that I have that derivative by itself. So we will have 4x dy over dx plus 2y dy over dx. And I'm going to move this and this both to the right side of the equation. So minus 2x minus 4y. And then again, we would factor out the dy over dx and then divide by what we would have left. So negative 2x minus 4y divided by 4x plus 2y. And then I want to evaluate that at this point. Okay, so I want to find dy over dx at the point 2, 1. So that's going to give me -2 times 2 minus 4 times 1 over 4 times 2 plus 2 times 1. That's going to give us -4 minus 4 over 8 plus 2. So that's -8 over 10, which I will reduce to -4/5. So that's our slope. So y equals negative 4/5 x plus b. And then I'm going to plug in 1 for y, 2 for x, solve for b. So that would give us negative 8/5. And if we add that over, that's going to be, if I add that to 5/5, that's going to be 13/5 is what we're going to get for b. So our equation is going to be y equals negative 4/5 x plus 13/5. So again, equation of tangent line, that's the directions on number 14. Find the derivative, plug in the point, and then use y equals mx plus b.